Hello everybody, I am Syed on Maths Online. Today's topic is solution of Lagrange Linear PDE. Equation of the form PP plus QQ is equals to R is called as a Lagrange Linear PDE, where the small p is nothing but dou z by dou x, small q is nothing but dou z by dou y. It is capital P, Q and R are functions of the partial derivatives. Now to solve this Lagrange linear PDE, we use the auxiliary equation of the form dx by capital P is equals to, it is dy by capital Q is equals to dz by capital R. If you want to find out the solution of this Lagrange linear PDE, we'll try to take the first two expressions and we get one solution. So let us take that solution to be, say, u, and we'll try to group another two expressions, dy by q is equals to dz by r, and try to find out another solution. Let us take that solution as v. Now if we try to group these two solutions, we get the solution in the form of, say, phi of u comma v is equals to 0. So this gives the solution for the Lagrange linear PDE. So let us take an example and see. Solve x times of dou z by dou x plus y times of dou z by dou y is equals to z. Now this equation can be rewritten in the form of x times of this dou z by dou x. We have taken that value to be equals to p, so x times of p plus y into this dou z by dou y, we have written it as q, so q is equals to this z as it is. Now if you try to observe, this equation is of the form capital P into small p plus capital Q into small q is equals to R, which represents the Lagrange linear PDE. Here, your value of capital P, try to compare the value of capital P is how much? X. Your value of capital Q, the value of capital Q, what is capital Q value here? Capital Q value is y, and the right hand side value, capital R value is z. We have got P, Q and R. Now let us consider the auxiliary equation dx by P is equals to dy by Q is equals to dz by R. Let us try to plug in these values. It is dx by, the value of p is x is equals to dy by, the value of q is y, and dz by, the value of r is z. Now as I have shown in the procedure, you have to take the first two equalities. Dx by p is equals to dy by q to get the first solution u. So we will try to take these two equalities over here, that is dx by x and dy by y. If I consider these two equalities, I will be getting dx by x is equals to, it is dy by y. This equality is nothing but expression in the variable separable form, therefore we can integrate this one. So if we try to integrate it, so the integral will be integral of dx by x is equals to, it is integral of dy by y, plus you need to add some constant of integration whenever you try to integrate it. But if you try to observe this, integral of dx by x comes out to be log, integral of dy by dy comes out to be log. Therefore we need to add the constant of integration in terms of log. So let us take this log of c1. So if you try to integrate this, dx by x comes out to be log of x is equals to integral of dy by y is nothing but log of y plus this log of c1 as it is. Or if you try to rewrite this expression, log of x, take this log y on the left hand side becomes minus log of y is equals to, it is log of c1. This is in the form of log m minus log n. We can rewrite this in the form of log m by n. This is log x by y is equals to, you have log of c1. Since you have log on both the sides, if you try to eliminate it, you will be getting x by y is equals to c1, which represents first solution. So this represents your value of u. First solution has been obtained. Let us take this as equation number 1. If you go back to this expression, another two equalities you can consider. Dy by y is equals to dz by z. So if you consider the next equality, that is dy by y is equals to dz by z. Let us try to integrate this one. On both sides you will get integral of dy by y is equals to, it is integral of dz by z, integral of dz by z. So whenever you try to integrate, you need to add the constant of integration. Let the constant of integration be log of c2. So integral of dy by y is nothing but log of y is equals to integral of dz by z is nothing but log of z plus the constant log of c2 as it is. If you take this log z on the left hand side, I get log of y minus log of z is equals to, it is log of c2. We get log y by z is equals to log of c2. If you try to eliminate log from both the sides, you will be getting y by z to be equals to c2. So let us take this as equation number 2. So you got equation 1 as one solution and equation number 2 another solution. Now if you want to write down the final solution, it will be 5 of u comma v. U is from equation number 1, we have got x by, we have x by y. From equation number 2 we have y by z is equals to 0. This gives a solution for the Lagrange Linear PDE. Let us take another example. Solve p times of cot of x plus q times of cot of y is equals to cot of z. So if you try to rewrite this equation, we can write it in the form of cot of x into p plus cot of y into q is equals to cot of z. This is in the form of pp plus qq is equals to r, where the value of capital P is nothing but cot of x, the value of capital Q is cot of y, and the value of capital R is cot of z. So if you write down the auxiliary equation is nothing but it is dx by p is equals to dy by q is equals to dz by r. So let us try to plug in the values of p, q and r. We try to plug in the values, we get dx by the value of p is cot of x is equals to, it is dy by q value is cot of y is equals to, it is dz by r value is cot of z. This can be rewritten in the form of 1 by cot is nothing but tan, so you can write it as tan of x into dx. 1 by cot is tan, so it is tan of y into dy. 1 by cot is tan, so tan of z into dz. So now once again you can consider the first two expressions. So we get tan of x into dx is equals to, it is tan of y into dy. We are in the variable separable form, therefore you can integrate it. Is integral of tan of x into dx will be equals to integral of tan of y into dy. As we know that integral of tan x and tan of y gives us log, therefore we add the constant of integration as log of c1. So integral of tan will become log of secant of x, and integral of tan y will be log of secant of y plus it is log of c1. If you take log of secant y on the left hand side, that becomes minus log of secant of y is equals to, it is log of c1. Now this is in the form of log m minus log n form, so log m by n you can write. So it becomes log of secant of x divided by secant of y is equals to, it is log of c1. If we try to eliminate log from both the sides, we will get secant of x by secant of y is equals to c1. So we got the first solution. Now move on to the next equality. This one is the next equality. If you try to consider tan y into dy is equals to tan z into dz. So let us try to consider that one. It is tan of y into dy is equals to, it is tan of z into dz. So let us try to integrate it. We will get integral of tan y into dy is equals to integral of tan z into dz. As you know that integration of tan will be log, therefore we add the constant of integration as log of c2. So integral of tan is log of secant of y, that is nothing but log of secant of z plus it is log of c2. Log of secant of y as it is, take log secant z on the left hand side, it becomes minus log of secant of z is equals to, it is log of c2. That can be written in the form of log of, is log m minus log n form, log m by n, so it is secant of y by secant of z, which is nothing but log of c2. Or if you try to eliminate log from both the sides, we will get secant of y by secant of z is equals to c2. That's the next solution. So if you try to combine equation 1 and 2, we get the solution to be equals to 5 of, so check equation number 1. Equation number 1 is secant of x by secant of y, and equation number 2 is secant of y by secant of z. It will be equals to 0. So that gives you the solution. We solve y square z into p is equals to x square times of zq plus y. Now it is not in the standard form pp plus qq is equals to r, therefore we have to rewrite this one. So let us take this as multiply this x square inside, you will get x square zq plus you will get x square zq plus x square times of y will be x square y. But you have to get pp is already there, plus q you have to get, so q is over here, so let us take that on the left hand side. you will get y square zb, and that becomes minus x square z times of q is equals to, it is x square y. So now this expression is in the form of pp plus qq is equals to r. So therefore you have the value of p over here is nothing but your y square z, your value of q over here is with a negative sign, it is minus x square z, and your value of r, which is nothing but x square y. So now if you write down the auxiliary equation, the auxiliary equation will be dx by p is equals to, it is dy by q is equals to dz by r. So let us write down the value of p to be equals to y square z is equals to, this dy by the value of q is minus x square z is equals to, it is dz by the value of r is x square y. Now let us consider the first two equalities. So we get dx by y square z is equals to, it is dy by minus x square z. If we try to observe here, the z and z will cancel out. Since we need to separate the variables in this case, so we'll try to cross multiply this value of x square on this side, becomes x square times of dx. I'll retain the negative sign as it is. Take this y square on the other side, you get y square times of dy. Or if we try to rewrite it, it becomes x square times of dx. This minus sign, when it comes to the left hand side, it becomes plus y square times of dy is equals to 0. So it is in the variable substituble form, we can just integrate it. So if we try to integrate, this integral of x square into dx plus integral of y square into dy, and you need to add the constant of integration over here. The constant of integration, let us take that as c1. So integral of x square comes out to be x cube by 3 plus integral of y square will be y cube by 3 is equals to, the constant is c1. So you got the first solution. Now let us move on to the equality. So these two equalities we'll try to take. So the next equality that you have is, it is dy by minus x square z is equals to, it is dz by x square y. So here this x square and x square will cancel out. So therefore if you try to rewrite this expression, it is dy by this minus of z is equals to, it is dz by, you are left out with y. So let us try to separate the variables over here, y with y and z with z. Send minus z on the right hand side, it becomes minus z into dz. So now they are in the variable substituble form. You can further simplify this as y into dy, minus comes on this side, becomes plus z into dz is equals to, is 0. Now if you try to integrate this one, it is integral of y into dy plus it is integral of z into dz, and the constant of integration will be c2. Integral of y will be y square by 2 plus integral of z will be z square by 2 is equals to, you have the constant of integration as c2. Or if you take the LCM over here, LCM will become 2. So you get y square plus z square is equals to c2. Send that 2 on the other side, you will get y square plus z square will be 2 times of c2. So let us take this as equation number 2. So you got two solutions over here. Equation number 1 gives you the first solution, and equation number 2 gives you the second solution. So if you combine, you'll be getting 5 of, the solution is x cube by 3 plus y cube by 3. X cube by 3 comma y cube by 3. And the second solution you have is y square plus z square is equals to 0. So this gives you the solution for the Lagrange Linear PDE. all I have for this video. We'll continue in the next video. Thank you.